Series 8000 propagation path replicator is designed for wireless communication testing, including Wi-Fi and WiMAX. It's particularly advantageous for long-distance WiMAX, up to 5 to 6 kilometers. And of course, the advantage is that that testing that you would normally be reserved for field testing to determine performance in the presence of intentional and unintentional interferers, with multiple reflective surfaces over long distances, reflections off of buildings, and ground clutter, sea clutter, all of those obstacles that impede the reception of data and wideband signals over long distances. All of that can be reproduced in a system like the Series 8000. In this case, there are 2 radio ports. However, multiple radio ports are available. There are separate transmit and receive antenna ports for each of the two radios. Single port options are also available. However, external isolators and circulators can be used for that application as well. And this system can be configured for a direct path between the 2 transceivers, or a multipath to reproduce the signal propagation off of multiple surfaces. Moving target generation and the Doppler associated with them can be reproduced with these systems, along with the propagation loss that you'd expect to see over both the direct path and the unintended reflected paths. We're looking here at the Eastern OptX Series 5000 Doppler generator. Now this Doppler generator can be supplied as a standalone unit like this, or built into any of the Eastern OptX radar system target generators or radar altimeters. In this case, the Doppler generator is being used to add a Doppler shift to a 7 gigahertz source here. So on this spectrum analyzer, you can see the unmodulated Doppler, the unmodulated 7 gigahertz signal, and this displays the typical GUI for the Doppler generation. If I turn the Doppler generator on, you can see now I have added in this case, 10 kilohertz Doppler shift to the primary signal. So a typical sideband and carrier suppression of about 35 dB is possible in the free running mode, and more than 50 dB of suppression is possible in the synchronized mode. So the carrier signal was here. Now it's being shifted up by 10 kilohertz in this case. It's also possible to provide a negative shift. So both a preceding and receding target can be generated. So if I change the Doppler frequency here to a negative shift, in this case minus 2,000 kilohertz, we get a shift, of course, in the negative direction. Doppler generation can be done by entering actually the Doppler frequency, or in the case of a moving target, the target velocity and carrier frequency can be entered, and the system will calculate the appropriate shift for that condition. As I mentioned before, the standalone version is available for external Doppler modulation, or it can be built into any of the Eastern OptX, either Series 3000, 1000, or 6000 systems, and can be used together with the propagation delay feature of those systems and the Doppler generation to create a complete moving target signature with both the Doppler shift and the shift in time delay. So this is our typical example of a Series 3000 radar target generator. This system is a discrete delay, so the delay can be selected from either the front panel here, any of these pre-programmed delays, or there's an external delay option, which is convenient if the original configuration is not suitable for some subsequent system improvement or maybe a different system. The external delay option is useful in those cases. The display here shows a radar pulse initially broadcast from the radar, and then the subsequent received pulse. And as you can see, as we change the distance from the target, we of course change the distance of the pulse, return pulse back to the radar. You may also notice at the same time that the level of the signal changes, which of course corresponds to the expected loss of that signal once it's transmitted, and that is either user programmable or it can be coupled to the particular distance that's selected. So for example, if a target is 10 kilometers away and the system is operated in the coupled mode, it will attenuate the signal appropriately for that distance. In the manual mode, the user can, in addition to propagation loss, add the expected loss from according to the radar cross-section of the target. So it's useful in both respects.